Welcome again, Wildcats. Today, we're looking at Friday, November 11th, solving radical equations, and that's going to be on page 33. So if you would, pause the video and update your table of contents. All right. So, solving radical equation steps. Step 1, isolate the radical. Step 2, raise both sides of the equation to the power equal to the index of the radical. Step 3, simplify and solve. Now, you're probably asking, what is the index of the radical? So I'm going to ask myself the same question. What is the index of the radical? The index of the radical tells what kind of root it is. So if you have the square root of x, the index is 2. If you have the cube root of x, the index is 3. Dot, 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 dot. If you have the nth root of x, the index is equal to n. Thank you for letting me know what the index of the radical is. No problem. Anytime. All right. So, if you would, update your notes. All right. Now that your notes are updated, let's look at the examples. All right. Example number 1. Now, what I recommend you do, by the way, is start writing all the way to the left because you need room. And in fact, what I'm going to do is I'm going to draw a light line just to kind of warn myself, don't go past this line because we need some space to write. Okay? All right. So it says step 1, isolate the radical. So to do that, by the way, this is square root, so that's a 2. We're going to divide both sides by 2. So when you do that, you get the square root of x plus 1 equal to 14 divided by 2, which is 7. Okay? Now, and I'm going to go ahead and put the 2 there to remind me what the index is. Okay? So step 2, raise both sides of the equation to the power equal to the index of the radical. So the index of the radical is 2, so we're going to square both sides. Now, a lot of teachers would just cross it out and say, well, that's what they do. But let me show you what's mathematically happening so that we can just draw this line across like here. Okay? And basically say that this and this, okay, go away. But they don't really go away. Let me show you what mathematically happens. So I'm going to rewrite this as x plus 1 raised to the 1/2 power. And again, I'm using the properties of exponents that we learned a couple days ago. Okay? That's equal to 49. Okay? Now, we know from the properties that when this happens, that we multiply the exponents. So 1/2 times 2 is 1. So you get x plus 1 to the first power equals 49. Now, anything raised to the first power is itself, so we can basically say that we have just x plus 1. Okay? Well, now we in step 3, simplify and solve. So we subtract 1 from both sides. X equals 48. Now, the reason why we have this side is you need, on these types of problems, you need to check your answer. Okay? We want to verify that, in fact, x equals 48 solution. And if it is, when we substitute 48 in for x, the left side will equal the right side. So let's do that. So you get 2 times the square root of 48 plus 1 equal to 14. Well, we know that 48 plus 1 is 49. So you get 2 times the square root of 49 equals 14. Well, we know that the square root of 49 is 7, and 7 times 2 is 14. So 14 equals 14. So we know that x equals 48 is a solution. All right, let's look at example 3. And again, the index here is 2. Okay, so we're going to isolate the radical. Well, we can't do anything else to isolate it. The 5 just have to stay there because we can divide it, but really we just leave it there. There's no more isolating. So next step is to raise both sides of the equation to the power equal to the index of the radical, which the index of the radical is 2, so we're going to raise that. Now we know that this can be rewritten as 35 raised to the 1/2 power, and that's being squared. And that 1/2 is kind of hard to see. You write it a little bit. 1/2. Okay? And that's equal to 5 square root of x plus 2 times 5 square root of x plus 2. Just made it in a line. Okay? Now, we know from properties that when the situation occurs, that 1/2 times 2 is 1. So that's technically 35 raised to the first power. So that's just 35. So that's where you can just come over here and say, and really, that's a 1. So you can say that these become 1. Okay? So it becomes 35 raised to the first power. Okay? Now here, I'm going to rewrite this as, and I should have rewritten this on the left. So what I want you to do is I want you to close your eyes or pause the video for about 30 seconds or so, and then look, because I want to rewrite all this on the left so we have room. So just pause the video. Okay? So we can do that. All right. So, as I said before, this becomes 1. So this is 35 to the first power. Now, 5 times 5 is 25. And this is x plus 2 to the 1/2 times x plus 2 to the 1/2. Now, we know from the properties of exponents that this times this, we add the exponent. So that's 1/2 plus 1/2, which is 1. So this becomes 25 times x plus 2 raised to the 1 power. But we don't need to write the 1. Okay, so now we're going to distribute. So you get 35 equals 25x plus 50. Now we're going to do 2 steps in 1. We're going to subtract 50 from both sides, which gives you negative 15, and divide by 25, so you get x equals negative 15 divided by 25. Equals negative 3 divided by 5. And again, this is why we have room is to check. Now, I apologize if I pause at any time. I'm at war with a fly here in this room, so I'm going to use my paper lightsaber to defeat the fly. So I think my paper lightsaber is scared the fly away, but again, if the fly shows up, I'm gonna have to pause and take my paper lightsaber and defeat the fly. Okay. All right. Now we need to check. So we're gonna plug that in. So then we get the square root of 35 equals 5 times the square root of -3/5 plus 2. And this is a great opportunity to show you that you can use a calculator to check. So let me clear this out, and I'm going to do Control X squared 35 equals, well, wait a second, get that equal sign. Now see how the cursor's inside? We need to click to the right to get it out, equals Control X squared, wait for it, equals 5 Control square root -3 divided by 5 plus 2. Now, if we did this correct, it'll say true. If we didn't, then the answer is not x equals -3/5. So it says false. Let's see what this little error thing says. Result obtained using approximate arithmetic. Interesting. So this is a great opportunity to realize that the calculator doesn't always give you what you need, so we can try different routes. Okay, so let me show you what I mean. Okay, let's do the left side and the right side separately. So 5 control square root -3 divided by 5 plus 2. So what you'll see is that the left and the right side are the same. So we can say that x equals -3/5 has been checked and it is the solution. All right, so let's look at example 5. All right, step 1, isolate the radical. Well, the radical is isolated. Step 2, raise both sides of the equation to the power equal to the index of the radical. So the index of the radical is 2, so we're going to raise both sides by 2. Well, as I've talked before, we know that when we use the properties, you'll get x to the 1/2 raised to the second power. Sorry. So this is x plus 18 equals to x minus 2, x minus 2, times x minus 2, sorry. All right. Now, I kind of hinted at this in an earlier lesson that, yes, the box method is great, but I want you to understand, if you had to do the box method, you take up so much space here, okay? That's why FOIL is important, okay? So we're actually going to FOIL this, okay? So x times x is 1x squared. X times -2 is -2x. -2 times x is -2x. -2 times -2 is a positive 4 plus 4. So that's why it's important to know FOIL and the box method, because the FOIL helps you save tremendous space here, okay? Now, I'm going to put a 1 there. So 1x plus 18 equals, combine like terms, so you get -4x plus 4. Now, in order to solve, you need everything to one side. So it looks like most of it's over here. So let's move all of this here. So I'm going to subtract 1x from both sides. Notice that I put the 1x with the 4x, and then I'm subtract 18, and notice I put the 18 with the 4. Well, this becomes 0, this becomes 0, so you get 0 equals 1x squared minus 5x minus 14. Okay? Now, at this point in class, if you don't like what I'm about to do here, you can ask me and I'll show you how you can use the reverse box method to factor this. But we're going to use some logic. Okay? We know that x times x will be, and what I'm actually doing is reverse FOIL. So since I did FOIL here, let's do reverse FOIL here. So 1x and 1x is 1x squared. Now you have to figure out what numbers multiply to give you negative 14, but add to be negative 5. So we know that 1 times negative 14 gives you, right here, we know that 1 times negative 14 is negative 14, and the only option is 2 times negative 14. Well, you have to ask yourself, which of these combinate, oh, actually, what is 2 times negative 14? What am I doing? That's 2 times negative 7. Well, the question you have to ask yourself is, which combination will multiply to give you negative 14, but add to be negative 5? The only possible option is 2 times negative 7. So we have x plus 2 minus 7. And you could FOIL this out. X times x is 1x squared. X times negative 7 is negative 7x. 2 times x is positive 2x. And you'll see that the negative 7x and the 2x become negative 5x. So here you go. All right. So now we need to set each of those equal to 0. So x equals negative 2 and x equals 7. Okay, and we need to check. Okay, so first we'll substitute negative 2 in to here. So that's the square root of negative 2 plus 18 equals negative 2 minus 2. Well, negative 2 plus 18 is 16. The square root of 16 is 4. Negative 2 minus 2 is negative 4. These do not equal. So negative 2 is not a solution. Okay, so now let's try 7. All right, well, 7 plus 18 is 25. The square root of 25 is 5. 7 minus 2 is 5. So we can say that x equals 7 is a solution. That's why checking is important, because you see here that negative 2 does not check, but 7 does. Okay? All right, let's look at one more example. All right, so step 1, isolate the radical. Well, the radical is isolated. Step 2, raise both sides of the equation to the power equal to the index of the radical. Well, in this case, I'm going to rewrite this as the cube root, again using the properties of powers, so you can see that the index is 3, so we're going to cube both sides. Okay, well, we know that this is x to the x plus 5 to the 1/3 power raised to the third. We know we multiply, so that becomes 1. So this becomes x plus 5 raised to the first power. So x plus 5 equals 3 cubed is 27. Subtract 5, x equals 22. Okay, so then we check. Okay, so then we substitute 22 in for x, so we get 22 plus 5 raised to the 1/3 power equal to 3. We know we can rewrite this as the cube root of 27 equal to 3. We know the cube root of 27 is 3, so 3 equals 3. So we can say that x equals 22 is the solution to the equation. I'm going to leave you with this. I just wanted you to know that no flies were harmed in the making of this video. And I'd like to wish you a terrific Wildcat